Thank you for listening. This course was created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional podcasts, books, newsletters, and cool merchandise await. Let's get started. An application programming interface, or API gateway, is a centralized entry point through which all client requests pass before reaching back-end services. In the context of artificial intelligence systems, this becomes the front door for every interaction with models, data stores, and supporting tools. Instead of letting traffic scatter across multiple services, the gateway consolidates control, providing consistency in how authentication, routing, and monitoring occur. For AI, this control is essential because inference requests can be computationally expensive and security-sensitive. A gateway ensures that every request, whether from an internal team or an external partner, is subject to the same rules. This centralization not only simplifies management, but also creates a foundation for robust defenses, where threats can be stopped at a single, predictable point before they ripple downstream into fragile or costly model environments. A proxy, in contrast, plays a more specialized role as an intermediary between clients and models. While an API gateway governs the broader flow of requests, proxies often focus on filtering, logging, and policy enforcement at a more granular level. For example, a proxy might inspect individual requests for dangerous tokens, sanitize outputs from a language model, or capture detailed logs for compliance reporting. Proxies add observability and policy enforcement without requiring direct modification of the model itself. By layering gateways and proxies together, organizations build a defensive chain. The gateway establishes the perimeter, and the proxy enforces rules deeper inside the interaction. This combination reflects the principle of defense in depth, where multiple safeguards work in concert to limit exposure and provide assurance. The roles of gateways and proxies in AI security extend far beyond routing convenience. They actively protect inference application programming interfaces from abuse, ensuring that sensitive services are not exposed directly to the Internet. By controlling access to resources, gateways prevent unauthorized users from consuming compute cycles or draining quotas. Proxies reinforce this by applying content-specific rules, such as blocking outputs that might violate compliance requirements. Together, they isolate back-end models from uncontrolled access, creating a buffer that shields fragile or costly systems from direct attack. These roles also help enforce consistent governance, ensuring that organizational policies apply uniformly regardless of which team or application is making the request. In essence, gateways and proxies translate security policy into live operational enforcement. Authentication and authorization are core capabilities of gateways in particular. Token validation at the gateway ensures that each request comes from a recognized identity, reducing the chance of spoofing or unauthorized use. Integration with enterprise identity systems, such as single sign-on platforms, ties AI services into broader corporate security. Policy-based access control enables fine-grained rules, allowing certain users to run limited types of inference or consume specific endpoints. Multi-tenant isolation ensures that one customer or department cannot inadvertently or maliciously access another's data or results. By applying these controls at the gateway, organizations build assurance that their AI services are not only functional but also responsibly managed. Identity becomes a first-class citizen in every interaction with a model. Rate limiting and quotas extend this protection into the realm of usage patterns. Without controls, a single client could flood a model with requests, leading to denial of service conditions or skyrocketing costs. Gateways can establish per-user thresholds, ensuring fair access across all tenants. These measures also prevent what some call denial of wallet, where adversaries attempt to bankrupt a service by consuming costly inference cycles. Quotas introduce predictability in resource consumption, allowing organizations to plan budgets and provision capacity more effectively. Abuse detection systems built into gateways can identify suspicious surges in traffic, enabling rapid response before they cause damage. In AI services where costs and risks scale with demand, rate limiting and quotas are not luxuries, they are necessities. Payload validation adds another line of defense at the entry point. By enforcing request schemas, gateways ensure that inputs conform to expected structures, rejecting malformed or incomplete data. This validation reduces the risk of errors cascading into back-end systems and makes exploitation harder. Special character sanitization prevents injection attacks, where malicious prompts attempt to bypass filters or manipulate outputs. For AI models, this step is particularly valuable because prompt injection and adversarial inputs are active areas of attack. Catching them at the gateway prevents harmful payloads from reaching sensitive models. Early rejection not only improves security, but also saves compute resources by discarding invalid or malicious requests before they consume valuable inference time. In this way, payload validation acts like a firewall for data quality and intent. Output filtering through proxies provides protection on the return path, ensuring that model responses are safe before they reach the client. Even trustworthy models can occasionally generate outputs that violate policy or introduce risks. Proxies can scan these responses for disallowed content, personal data, or non-compliant phrasing. They may block harmful text outright, redact sensitive fields, or apply formatting rules to standardize results. This additional checkpoint ensures that compliance obligations are enforced at the edge, without burdening every application developer with their own filters. In effect, proxies act as editorial guardians, shaping outputs so they meet both ethical and operational expectations. This step also provides reassurance to stakeholders that the system does not simply trust the model blindly, but actively monitors and moderates what it produces. Observability at gateways and proxies turns routine traffic into valuable security telemetry. By logging request metadata such as timestamps, user identities, and endpoint targets, organizations gain visibility into how their models are used. Latency monitoring highlights performance bottlenecks and helps distinguish between legitimate surges and potential attacks. Anomaly detection can reveal unusual access patterns, such as sudden bursts from a new region or spikes in malformed queries. Forensic evidence collection preserves detailed logs that investigators can review after an incident, enabling root cause analysis and remediation. This observability transforms gateways and proxies into more than traffic managers. They become early warning systems and investigative tools, helping organizations respond intelligently to evolving threats. Encryption and confidentiality measures ensure that data passing through gateways and proxies remains protected. Terminating transport layer security, or TLS, at the gateway provides a secure front door, while secure back-end connections maintain encryption as data flows to model servers. Proxies can also establish encrypted tunnels, ensuring that even internal communications are shielded from eavesdropping. Regular certificate rotation reduces exposure if credentials are compromised. For AI systems handling sensitive data, such as healthcare records or financial transactions, these practices are not optional. They provide confidence that information remains confidential from the moment it leaves the client until the processed response is returned. Encryption transforms gateways and proxies into guardians of both integrity and privacy, critical qualities in regulated environments. Integration with Security Information and Event Management, or SIEM platforms, amplifies the value of gateway and proxy data. By forwarding logs to a centralized monitoring system, organizations can correlate AI traffic with signals from across the enterprise. Dashboards provide a unified view of system health, while automated triggers raise alerts when thresholds are breached. Events at the gateway, such as repeated authentication failures, can be correlated with other suspicious activities, such as network scans or endpoint anomalies. This integration makes AI infrastructure a visible part of the larger security posture, ensuring that incidents are not overlooked simply because they occur in a specialized environment. Gateways and proxies thus become contributors to the enterprise's collective defense, rather than isolated silos. Scalability and performance considerations ensure that security controls do not become bottlenecks. Distributed gateway clusters spread the load, providing resilience and redundancy under high demand. Caching frequent responses reduces repeated strain on expensive models, improving both speed and cost efficiency. Load balancing mechanisms ensure that no single backend service is overwhelmed, while proxies can offload tasks like logging or filtering to specialized nodes. Designing for resilience under spikes allows the system to withstand both natural traffic surges and hostile floods. Balancing these capabilities requires careful engineering. Too much filtering can slow responses, while too little can weaken protection. Scalability ensures that gateways and proxies remain assets even as usage grows, rather than liabilities that drag performance down. Governance enforcement elevates gateways and proxies from technical components to policy executors. Codified rules ensure that organizational requirements are not just aspirational but enforced at runtime. Audit-ready configurations demonstrate compliance to regulators or internal auditors, showing exactly how policies translate into practice. Traceability of access decisions, why a request was permitted or denied, creates accountability and transparency. Compliance alignment guarantees that standards such as data protection regulations are observed consistently across all traffic. Governance enforcement makes gateways and proxies more than operational aids. They become living embodiments of corporate rules, carrying the weight of organizational intent into every model interaction. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Zero Trust principles integrate seamlessly into the philosophy behind gateways and proxies. In a zero-trust architecture, no request is trusted by default, even if it comes from within the organization's network. Every interaction is authenticated, authorized, and continuously validated. Gateways make this possible by verifying tokens and identities at every hop, while proxies enforce additional segmentation within services. Removing implicit trust limits the blast radius of compromises, ensuring that a breach in one area does not provide unfettered access elsewhere. Adaptive enforcement allows rules to adjust based on context, for example, raising scrutiny during unusual login attempts or spikes in traffic. By embedding zero trust into gateway and proxy configurations, organizations achieve a posture where security is not assumed but actively asserted at every step of the request's journey. API gateway tooling provides the practical means to implement these principles. Commercial enterprise platforms deliver features like built-in identity integrations, compliance certifications, and robust monitoring dashboards, making them attractive for large-scale organizations. Cloud-native services offer elasticity, spinning up resources automatically to match demand, and integrating closely with other managed cloud tools. Open-source frameworks provide transparency and flexibility, appealing to teams who want fine-grained control over configurations without vendor lock-in. Extensibility via plugins allows gateways to adapt over time, adding modules for custom validation, logging, or filtering. Each option comes with trade-offs. Enterprises may prize support and compliance guarantees, while smaller teams may prioritize agility and customization. Regardless of choice, the goal remains the same: ensuring gateways serve as secure, reliable entry points to AI systems. Proxy tooling extends these capabilities with a different emphasis. Reverse proxies are a traditional deployment pattern, sitting between clients and back-end services to mediate all traffic. Sidecar service meshes, popular in microservice architectures, embed proxies alongside individual services, enforcing localized policies while coordinating globally. Filtering proxies can be tuned specifically for AI workloads, scanning prompts for injections or outputs for disallowed content. Observability integrations turn proxies into sources of telemetry, collecting granular data on each transaction for monitoring and forensic purposes. As with gateways, organizations must match proxy tools to their needs. Some may require lightweight filtering while others demand comprehensive service meshes. The unifying theme is that proxies add depth to defenses, catching what gateways may miss, and providing oversight closer to the model's behavior. The risks of operating without gateways or proxies highlight their necessity. Direct endpoint exposure leaves AI models vulnerable to brute force queries, denial of service floods, or automated adversarial probing. Without centralized controls, credential abuse becomes more likely, as identity checks vary inconsistently across services. A lack of monitoring signals means organizations cannot distinguish between legitimate surges and hostile campaigns, leaving them blind to developing threats. Inconsistent enforcement creates a patchwork of protections, with attackers naturally gravitating to the weakest links. In such environments, models become soft targets, and operational surprises are inevitable. The absence of gateways and proxies is not a neutral choice. It is an open invitation to inefficiency, inconsistency, and exploitation. Operational best practices ensure that gateways and proxies deliver reliable, secure performance over the long term. Applying the principle of least privilege restricts access so that users and applications only receive the rights they need, reducing exposure in the event of compromise. Layered enforcement policies distribute checks across gateways, proxies, and back-end services, creating redundancy in case one layer fails. Automated policy updates allow systems to evolve quickly as threats change, minimizing lag between detection and response. Regular configuration audits confirm that deployed settings match organizational standards, catching drift or errors before they create vulnerabilities. These practices prevent controls from becoming stale or brittle, ensuring gateways and proxies remain trustworthy components in an evolving environment. Metrics provide visibility into the effectiveness of gateways and proxies, turning abstract policies into measurable outcomes. Tracking blocked request rates shows how often defenses are actively preventing malicious or non-compliant activity. Monitoring throughput under load demonstrates the resilience of the infrastructure under pressure. Measuring latency overhead clarifies the performance cost of security controls, enabling organizations to balance protection with user experience. Error propagation analysis reveals whether failures at the gateway cascade into outages for dependent services, pointing to areas where resiliency must be strengthened. By collecting and reviewing these metrics regularly, organizations create feedback loops that guide continuous improvement. Gateways and proxies thus become not just protective tools, but measurable, optimizable assets within the AI security ecosystem. The strategic importance of API gateways and proxies becomes evident when viewed as foundational pillars of secure AI deployment. They do not merely route traffic, they enforce the discipline needed to manage trust, usage, and compliance across diverse systems. By centralizing entry points, they prevent fragmentation of controls, ensuring that all model interactions follow consistent rules. This consistency reduces the risk of oversight gaps and provides a reliable framework for scaling. Without gateways and proxies, organizations often rely on ad hoc enforcement, which is fragile and prone to human error. With them, security becomes systematic, embedded in infrastructure rather than scattered across teams. They serve as the connective tissue between governance policies and the technical systems that must enforce them in real time. Trusted scaling is another dimension of their importance. AI services often grow rapidly, both in traffic volume and in business criticality. Gateways enable this scaling by managing load balancing, caching, and throttling, while proxies ensure that filtering and observability grow in tandem. Together, they allow organizations to meet rising demand without sacrificing security or governance. For example, a customer support chatbot may start with modest use but expand globally. Without gateways and proxies, growth could quickly outpace the ability to monitor, enforce policies, or control costs. With them, the system grows gracefully, maintaining trust in both the reliability of services and the safeguards surrounding them. Trusted scaling is not just about performance, it is about ensuring growth does not undermine security. Avoiding operational anti-patterns ensures that gateways and proxies achieve their potential. One mistake is deploying them only for convenience, treating them as mere traffic routers rather than as policy enforcers. Another pitfall is neglecting regular audits, leading to configuration drift, where deployed rules no longer reflect intended policies. Over-customization can also backfire, introducing complexity that makes systems fragile and hard to manage. Best practice emphasizes clarity, codification of rules, and automation to reduce manual errors. Canary deployments, where new rules are tested on limited traffic, provide assurance before full rollout. Regular drills to simulate failures or attacks confirm that controls respond as expected, under stress. These practices keep gateways and proxies aligned with their security mission, rather than drifting into underused infrastructure. The governance role of gateways and proxies extends beyond technical configuration. By enforcing policies consistently, they provide evidence of compliance for auditors and regulators. This is increasingly important in environments where AI systems face scrutiny for privacy, bias, and accountability. Gateways document who accessed what, when, and under what conditions. Proxies capture detailed interaction logs, which can demonstrate adherence to policies or help reconstruct events in investigations. Together, they bring visibility and traceability that transform abstract governance requirements into concrete operational proof. This is vital for maintaining stakeholder confidence, particularly in industries like finance, healthcare, and government, where AI services must withstand regulatory oversight and public trust. In conclusion, gateways and proxies are not optional accessories in AI infrastructure. They are essential guardians of trust, performance, and compliance. They authenticate and authorize users, validate and sanitize inputs, filter and monitor outputs, and provide observability at every stage. By integrating zero-trust principles, they eliminate assumptions and replace them with continuous verification. With strong tooling, operational best practices, and governance alignment, they evolve from technical components into strategic assets. Their importance lies not only in what they block, but in the trust they enable. Trust that services are secure, compliant, and ready to scale responsibly. As AI systems continue to expand in complexity and reach, gateways and proxies provide the stability and assurance needed to navigate this growth safely. As we transition to the next topic, code execution security, the link becomes clear. Gateways and proxies control how requests enter and leave models, while code execution controls address what happens when models act on those requests internally. Together, they represent two halves of a holistic defense strategy, one securing the borders, the other safeguarding the actions within. By mastering gateways and proxies, you build the confidence that what reaches your models is legitimate and what leaves them is appropriate. With that foundation, you are ready to examine the risks and defenses surrounding the execution of code and tools in AI systems, the next frontier of operational security in this journey. Thanks for tuning in to Bare Metal Cyber, your trusted source for cybersecurity educational materials, news, and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.